In this class, let us learn about congruent triangles. Congruent figures are figures which have the same shape and same size. Now, consider this figure and let us see 4 examples. 2 which are congruent and 2 which are not congruent. Now look at the first one. Look at these two. You can just see that they have the same size, but the shape is not same. That means these two are not congruent. Look at the next one. It has the same shape but not the same size. Such figures are called similar figures. So similar figures are figures which have the same shape but they are of different sizes. One may be bigger than the other. So such figures are called similar figures. So this figure is a similar figure. Now the third one, you will see that it has the same size and the same shape. So this one is congruent. So when are two shapes called congruent? When you take this and superimpose on this, or in other words, if you take this and place this on this second figure, it should completely and exactly cover it. So then it is called congruent, or in other words, it should have the same shape and the same size. Now look at the fourth figure. You can see that it has the same size and the same shape. But how is it looking? If you take this and superimpose on this one, you will see that it does not cover it. Right? Look how it is looking. If you take this and place this over, it's not going to cover, but it is still of the same shape and the same size. So it is congruent. When will it be congruent? Just rotate it. Rotate it 2 times to the right. Then it will end up like this. So it is just like these two pens, right? Just these two are of the same shape and the same size. Just because I place one like this does not mean that its shape is going to change. So this is also congruent. All you have to do is rotate it 2 times and then it will be congruent. Then in this class we are studying about congruent triangles. But what are triangles made of? They are made of lines and angles. It is made of 3 lines making 3 angles among themselves. So before going to the congruent triangles, we will see what makes 2 line segments congruent. 2 line segments AB and CD. They are said to be congruent if they are of the same measure. If AB is 1 centimeter, then any line segment which has the same length will be congruent to it. Now next, what makes 2 angles congruent? Suppose you have 2 angles, ABC and DEF. What makes these 2 angles congruent? They must be of the same measure. Suppose this is ABC. Suppose this is 30 degrees. Any angle which has the measure 30 will be congruent to it. And please notice here that how I have drawn the arms. See the arms AB and BC, they are very much smaller than DE and EF. Why is that? Because the arms do not matter. The arms do not have to be same. Only the measure has to be same. Whichever angle is 30 degrees, it will be congruent to ABC. So this is how we establish the congruence of line segments and angles. Now we go on to the congruence of triangles. Now let us see what makes 2 triangles ABC and DEF congruent to each other. So before that, tell me how many elements are there in a triangle. it has how many vertices? This one, 3 vertices. A is a vertex, B is a vertex, and C is a vertex, right? And next, it has how many sides? Again has 3 sides, AB, BC, and CA. Please notice here that I have written it in order. Whether you write it as AB or BA, it is all the same. But it is always better that you stick to the order, because that will make you avoid mistakes. So always stick to the order, AB, BC, and CA. And how many angles? Angle A, angle B, and angle C. So this is how your triangle ABC will look like, right? So if triangle ABC is congruent to triangle DEF, it means that the first vertex here coincides with the first vertex here. The second vertex coincides with the second one, and the third vertex coincides with the third one. Similarly, the first side AB is equal to DE, and BC is equal to EF, and CA is equal to FD. And notice DF, FD, it's all the same, but please stick to the order. Similarly, angle A is equal to angle D, angle B is equal to angle E, and angle C is equal to angle F. Or in other words, if you have two triangles like this, in such a way that AB is equal to DE, BC is equal to EF, and AC is equal to DF. So see, whichever lines, you can see which all lines are equal by noticing how many cuts are on it. So if the ones which have one cut are equal to one another, the ones which have two cuts are equal to one another, and the ones which have three cuts are equal to one another. Or in other words, if this is 3, this will also be 3. If this is 4, this will also be 4. If this is 6, then this will also be equal to 6. And similarly, the angles also coincide. This angle will be equal to this angle, this angle will be equal to this angle, and the third one, these two will be equal. Or in other words, if you take this triangle and put it on top of this, it will completely and exactly cover it. So that is what congruent triangles mean. It means the vertices correspond with each other, the sides correspond with each other, and the angles correspond with each other. So does that mean that every time we have to prove that two triangles are equal, we have to check all these 9 things? 3 vertices, 3 sides, 3 angles, 9 elements. Do we have to check it every time? Luckily, no. That is what we are going to study, something which is called the congruence criterion, which is going to make our life a lot easier. The first congruence criterion is known as the side, or in other words, the SSS congruence criterion, which means if you have a triangle ABC with sides say 3 centimeter, 4 centimeter, and 5 centimeter, what this congruence criterion says is that any triangle which has the sides of the similar measure will be congruent. You don't have to worry about the angles, you don't have to worry about the vertices corresponding with each other. So let us see 2 examples. Another one, triangle DEF. Now out of these two, which triangle will be congruent to this? Its sides are 3 centimeter, 4 centimeter and 5 centimeter. So look, check this, 3, 5 and 6. So this is not congruent. But what is congruent? This one. See, it has 3 centimeter, 4 centimeter and 5 centimeter. So this is the one which is congruent. This will not be congruent because it has different sides. So any triangle which has the 3 sides will be congruent. But then how do we write the congruence? ABC will be congruent to what? Will it be congruent to PQR or RQP or PRQ? If you remember the first example that we saw, that of a tree, you remember the last example? It was upside down and we had to rotate it 2 times to make it look congruent to the original tree. So how do we do that here? You see, this is also like not in the correct order, right? So how do you set the correct order? As I said, stick to the order. Write AB, then BC, then CA. Now AB is 3 centimeter. Which thing has 3 centimeter here? PR. BC is 5 centimeter. Which has 5 centimeter here? QR. CA is 4 centimeter. That would be PQ. So how will you write this? Look at here, AB, BC. So the vertex which comes first here, which comes second here, comes first here. So what is the thing which is being repeated here? It is R. So write that in the same order. Write PR, but don't write this as QR. Write this as RQ. See, AB, BC, PR, RQ. Now look at here, BC, CA. So the one which is the second here comes the first here. So here also see the same thing. Q comes second here. So in this place, Q should come first. So write it as QP. Now you have got it. ABC is congruent to PRQ. Not PQR, PRQ. Let us draw that and check if it is correct. See, A, where A is, we have to write P. Where B is, we have to write R. And where C is, we have to write Q. So PR is 3, RQ is 5, and PQ is 4. So see, what we did in that example, we just rotated it 2 times, that tree. So here we set it up like this, then we will get the congruent figure. This is the side congruence, which means any triangle which has these 3 sides will be congruent to this triangle. Or in other words, if you have 2 triangles which have the same set of sides, they will be congruent to one another. Now the second criterion is something which is called the side angle side criterion. Next is the side angle side criterion. That means if you have a triangle where 2 sides and the angle between them is known. 2 sides are known and the angle that they make with each other is known. Then any other triangle which has the same arrangement will be congruent to this. So any other triangle where there are 2 sides 3 and 4 and between them they make the angle 30, they will be congruent to this. Let us see one example which is congruent and one example which is not congruent. Now, see the 2 triangles. We have DEF and XYZ, 2 triangles. So which one is congruent? what we need is two sides. There should be 3 centimeter and 4 centimeter. That is fine, no problem. But then this 30 must be the angle that they make with each other. Here 3 and 4, what is the angle they are making with each other? It is this angle. So this should have been 30. But where is 30? 30 is here. 30 is the angle which this side makes with this side. So this is not SAS. This does not follow the SAS criterion. Now look at this picture. What do you see? 3 centimeter, good. 4 centimeter, that's also good. And the angle which they both make with each other, that is 30 degrees. So this follows the SAS criterion. So using the SAS criterion, we can safely say that these two triangles are congruent. But then ABC is congruent to what triangle? Is it XYZ or ZYX, or what triangle is that? And how do we find out? Again, using the same method, write that in order. AB, BC and angle B. Okay, so AB is 3. What is 3 here? XZ. BC is 4. What is 4 here? YZ. Angle B is 30 degrees. What is 30 degrees here? Angle Z. So what do you see here? AB, BC. So what comes second here is coming first here. So arrange it the same way. What is the alphabet you are seeing repeated here? Just like you are seeing B repeated here, what is the alphabet you are seeing repeated here? It is Z. So in the first place, Z should come second, and in the second place, it should come here. Right? So triangle ABC will be congruent to triangle XZY. Not XYZ, it is congruent to triangle XZY. Now we come to the third congruence criterion, which is called the angle side angle criterion. The third one is called the angle side angle criterion, which means if you have a triangle ABC, you know two of its angles. One you know to be 30 degrees, other one you know to be 45 degrees, and you know the length of the side between them. Suppose it is 7 centimeters. So any triangle which has the same arrangement, which has two angles which are 30 and 45, and the side between them is 7, however that angle is, it will be congruent to this. So for example, you have a triangle like this. This is 30, this is 45, and this is 7 centimeter. EQR. This is 30, 45. So which one among them will be congruent? Will XYZ be congruent, or will PQR be congruent? What is the angle side angle criterion tell you? Two angles and the side between them. Here you see two angles, 30 and 45. The side between them is here. That is not 7 centimeter. They have given this is 7 centimeter. So that information is no good for us. So this we cannot use the angle side angle criterion. But look at this. You have two angles, 45 and 30, and 7 is the side between them. So that is good news. This is congruent. Or in other words, if you take this and superimpose on this, you will see that it covers it completely and exactly. So these two will be congruent. Now there is another one criterion which is called the angle side criterion, which is, you will not see it described in many books. It is called angle side. That means if you have a triangle ABC and you know two of its angles, 30 and 45, and you know about a side which is not its common side, it comes here. Okay, if you have such a triangle, then any triangle which has the same arrangement, two angles 30 and 45 and one side which is not common to them, if that is 7 centimeter, such a triangle will always be congruent to this triangle. And this is actually not a direct criterion, because this is actually something which is derived. For example, if you have two triangles, suppose this is 30 and this is 45, and suppose this is 30 and this is 45, automatically it would mean that the third side is also equal. Why would that be? Can you guess? Because we know that the sum of the sides of a triangle is always equal to 180 degrees. Right? So if this is 30 and this is 45, what does this have to be? It has to be 105. Right? There is no other way out. This has to be 105. The same here. If this is 30 and this is 45 degrees, the sum has to add up to 180 degrees. Or in other words, this side will be less than 180 less than the sum of this, which is 75, right? So that is 105. This has to be 105. So what does that mean? If this is 30, this is 45 and this is 105 and this we know is 7 centimeter, then naturally that would mean, even though we are calling it the angle side, it actually goes back to angle side angle. Right? What have we done? Now we have got two angles and the side between them. Two angles and the side between them. So what is that? That is angle side angle. So though we started with angle AAS, finally we have arrived at ASA. So that is why this is basically a derivation. So whenever you have a triangle, so if you have a triangle whose two angles are known and a non-common side is known, any triangle which has the same arrangement, for example XYZ, if it has the same arrangement, 30, 45, 7 centimeter, this too will be congruent. Now we come to the last criterion, which is actually a special case, which is called the RHS criterion, that is only for right angles. Now we come to the last congruence criterion. It is a special case. This is only for right angles. It is called the RHS criterion, or the right angle hypotenuse side criterion. Or in other words, if you have a triangle, say ABC, which is right angled at say B, and suppose you know what the hypotenuse is, say suppose it is 7 centimeter and you know one of the sides, say 5 centimeter. Then any other triangle which has the same arrangement, that is the hypotenuse is 7 and any one of the sides is 5, will be congruent to this. Now as usual, we will see two examples, one which is not congruent and one which is congruent. There. So which one is congruent? Here the hypotenuse is 7, but look at the hypotenuse here, it is 5. So that means this is not congruent. The angle is fine, both are 90 degrees, that is fine, but we have different hypotenuses here, so this is not congruent. But what is congruent? This one. It has the same hypotenuse, it is right angled, and the other one of the sides is 5 centimeter. So this is congruent. So this is called the right hand side hypotenuse side congruence, or the RHS congruence criterion, which means that in a right angle, if the hypotenuse and one of the sides are equal, such two triangles will always be congruent. Now let us do a quick recap of what we have studied so far. So what did we study so far? We studied SSS. That means it is enough to know the three sides. If two triangles have the same set of sides, they will be congruent. Then the next one is SAS, which means two sides and the angle which is included between them. And then ASA, which means two angles and the side which comes between them is same. Then such two triangles will be congruent. And the last one was RHS, which is a special case. And we also studied AAS, but I'm not going to mention that because it is the same as ASA. So we studied all of this. Did you notice one thing? The first we had three sides, two sides, and then one side here. Here also one side, here two sides. So what does that mean? For congruence, you need at least one side. AAA is not enough to prove that two triangles are congruent. Why is that? I will show you. Now, see this triangle. Suppose this is 90, 45, 45. Now, look at this. See, same thing. This will be 90, this will be 45. So what are they? Remember the first example that we started with, that small tree which we drew. What did we call it? It is similar. It is similar, but it is not congruent. Why? With the same set of three angles, you can draw as many triangles as possible. That does not mean that they are congruent. They are similar. They look the same. All of them will look the same, but they cannot be superimposed on one another. You cannot take it and put it on top of the other in such a way that it completely and exactly covers it. So AAA is not a congruence criterion because it does not prove congruence, but it proves similarity. It is similar but not congruent. So now we have studied all the congruence criterions. Now let us do a few problems based on what we have learned so far. Now ABC is an isosceles triangle with AB equal to AC, and AD is one of the altitudes. So what do we mean by an altitude? If we have any triangle XYZ, an altitude is a line drawn from one vertex to the opposite side in such a way that it is perpendicular. So if XL is an altitude, that means XLZ is 90 degrees and XLY is 90 degrees. That's what an altitude means. So here what have they said? They have said that AD is one of the altitudes. So if AD is an altitude, what does that mean? It makes right angles here. So this is 90 degrees and this is 90 degrees. So what congruence criterion do we have to use here? RHS, right? So we already know that AB and AC are equal, which means because it's an isosceles triangle, so AB is AC is equal to AC, which is given, and angle ADB is equal to angle ADC is equal to 90 degrees. Why? Because AL is the altitude. And then AD is equal to AD. You have this as the common side, right? So what do we have? We have two triangles. I've just split this one figure into two. So what do we have here? Right angle triangle, equal hypotenuse and one side equal. So by RHS we have proved that ADB is congruent to ADC. Let us see one more question. Now, usually we take two triangles and compare them. Here, they are just part of one whole figure. So, what is given is that AC and BD are equal, AD and CB are equal. Then they are asking the triangle ABC, is it congruent to ABD or BAD? So, you see this figure, I'll draw the same thing, but I'll just split it into two different triangles. Just notice that it's the same thing, but I'm just splitting it into two. So you have DAB here, right? So this one and the other one here, right? What is drawn here as together, I have just split it into two, and then we will mark which all are equal. DA is equal to CB, so I will put one cut on both of that. CA is equal to DB. We have already put one cut here, so here I will put two cuts. And AB, it's same, right? So which congruence rule are we going to use here? You don't see any angle anywhere. So we are just stuck with the SSS rule, right? So, but the question is, we know ABC is congruent to this, but in what form? You remember the first example that we did, how we rotated that tree. So in what order is it congruent to this? Is it DAB or BDA or BAD or ABD? Which form? How much do we rotate it? That is the question, and we have already done it, right? Write AB, BC, CA. See the ABC, right? Here, just out of these two, stick to one. Take ABC, stick to that, and write its lines in order. Write its line segments in order. AB, BC, and CA. Write them down. So AB, same, right? BC, DA. CA, DB. Now, once we have written it down, let us arrange it in order. You see here AB, BC. So B is the one which is common. Here it will come first. Here it will come in the second position, and here it will come in the first position. So what is the one which is equal? Same here, A, right? We have A, B, D, A. So A is the one which is getting repeated here. So that in the first we should write it here, B, A. And here we should write it at AD. Does that make sense? See, AB, BC. Here B, here B. Just like that, BA, AD. Again, BC, CA. So C is the one which is getting repeated, the vertex which is common to both of these line segments, right? Just like that, what is common to both of this? It is D. So it should be AD, DB, right? AB, BC, BA, AD. BC, CA, and here like this. So what is it? So ABC will be congruent to which triangle? BAD, and then here it comes. So this is the correct answer. Now we will just do one more problem. Now the line segments AB and CD bisect each other at O. What is bisect means? Anything by is 2, tri is 3. So bisect means cut into two equal parts. So AB is cutting CD into two equal parts, right? So that means CO is equal to OD, and then CD is cutting AB into two equal parts. See the CD, it is cutting AB in such a way that AO is equal to OB, and we have to find out whether triangle AOC, this triangle, is congruent to this triangle. We know how to do it. We have to stick to the order, right? So write AO and then OC, right? What is AO equal to? It is equal to OB. What is OC equal to? It is equal to OD. But write it in a proper form. Here you see AOOC. So write it this also in the same way, that the common, the ending and the starting is the same letter. So what that actually means is that you will get the vertex. What this actually means is that if you arrange two line segments in the form AOOC, what it means is that you are getting a vertex where AO and OC are intersecting. So here also arrange it in the same way, so that it ends with the starts with the same alphabet and ends with the same alphabet. That would be BOOD. So we have two line segments which are equal, right? So now what can we apply here? We have SSS criterion, we have SAS criterion. Is there anything else we can find out? We have got two sides, right? So can we get another side or an angle? Look at this. This is the vertically opposite angle. So what is a vertically opposite angle? Where any two lines intersect, the angles thus formed are called the vertically opposite angles, and they are always equal. So this angle is equal to this angle. So it resembles the English alphabet X, right? So these two are equal. So what does that mean? Angle AOC is equal to angle BOD. So, but is AOC equal to DOB? The answer is no. Look here, triangle AOC. AOOC is equal to BOOD. Right? AOC is congruent to BOD. It is not DOB. It is BOD. So this is the right congruence. With this we come to the end of this chapter. In the next class we will learn to construct triangles based on these congruence criterions, SSS congruence criterion. Based on this we will see how to construct triangles, which is practical geometry. Inshallah, I'll meet you in the next class. Till then, stay safe.